And we will dive right into our next presentation, where we'll be hearing from Niantic, the Senior VP of Engineering, Mr. Brian McClendon.
Thank you very much, and I'm very excited to be here in Singapore. It's a beautiful city, and it's been a great experience. AR everywhere, all at once. My name is Brian McClendon. I'm SVP of Engineering at Niantic, and I'm going to talk today about what we're doing and what I've learned sort of in my history in the industry. But first, I'll talk about Niantic. So Niantic's mission is to inspire people to explore the world together. And I'll start out with, like, how many of you have ever played Pokemon Go? Pretty decent amount now. How many of you are playing it now? Statistically, do a bit better in the general population. But Pokemon Go was a huge introduction to this idea that you can go out and explore the world and have a shared experience where everybody saw more or less the same thing as they went around the world. And this was the prototype example of why we did this. We wanted to bring people together and experience the physical world. So we've built several games in this category, and I'll talk about some of them today. But you know us for Pokemon Go, but we've also had Ingress, which even preceded Pokemon Go, and more recently Pikmin Blue and Peridot. But what you may not know is that as of a few days ago, we launched Monster Hunter Now. Now it's in soft launch, but it happens that if you're in Singapore and you have an Android phone, you can try it right now. Now this is a new game, and here's the QR code if you want to download it, but please don't play while I'm talking. This is a very exciting new game. We've seen a lot of how the people interact with it. The intellectual property from Capcom is very powerful, but I think even people who've never tried Monster Hunter before or even seen the movie will have a great experience with this game. There were over 2 million pre-registrations, and we have a lot of hope for the adoption of this game. So, why am I here? What is my history? Well, you heard Ori in the beginning talk about 37 years since the professor first explained publicly what he'd been working on with virtual reality. Well, that exactly maps to my career. I joined Silicon Graphics. I started work in 86 and joined SGI in 88. And for those of you who don't know, Silicon Graphics was the first 3D graphics hardware company that really took off. It preceded NVIDIA and AMD and built the very first GPUs. Now, the problem was that our GPUs cost $100,000 to $200,000 a piece, and so it made for some very expensive development. This was back when enterprise computers were actually a much more common experience. So I got to see a lot of the very early developments of virtual reality. And for example, Disney Quest was a production use case that Disney put out using SGI machines, $100,000 per eye, and created theme parks where you could go experience virtual reality. This was in the mid to late 90s. It was a very interesting experiment. They learned a lot about developing virtual reality content, but it didn't take off. I then joined a company called Intrinsic Graphics, co-founded it with Michael Jones and Chris Tanner and Remy Arnaud, and we built a graphics platform, a game platform called Alchemy. And Alchemy, think of it as Unity about 15 years too early. Because it was cross-platform across all the game consoles at the time, as well as PCs, and it allowed for high-performance graphics to work consistently across machines. Our first demo of that was Google Earth. Before it was Google Earth, we called it Keyhole. Google liked it so much they acquired us, rebranded it as Google Earth, and John Hankey and myself led the Google Earth and Google Maps teams for 10 years. And we again built platforms around the Google Maps API and KML and watched people build experiences, both games and enterprise use cases, on top of our APIs. I then spent 2 years at Uber working on self-driving cars, learning a lot about a new kind of virtual reality that was much higher resolution, as well as learning about machine learning before it became as popular as it is today. I joined Niantic in 2019 and have been working on the augmented reality team. And I'm going to talk a little bit about our platform at Niantic. We focus on the ability for games, marketing, and developers to build augmented reality experiences across many platforms. So we integrate well with Unity. We also have a web-based platform. And we have a set of capabilities that we offer our developers that allow them to build the larger experiences that we've been building with some of our games. One of the biggest layers that we focus on is around this idea of the Niantic map. Now, many of you may remember Pokestops and the organization of the world. So Waysports are part of this, our Maps SDK, which I'll talk about. And finally, our visual positioning system, which is the ability to go to a location and locate yourself exactly and be able to reproduce content positioning within a few centimeters. I think this is a new capability that many of our developers are already taking advantage of. But I want to separate out a little bit two kinds of augmented reality. There's visual AR, which is very much what you see out the window, out your screen, and we'll be giving some examples of that. And then the location-based AR, which is how do you find yourself in the world and how do you find content around you. And so being able to walk around and navigate from your location to the next place where you want to find something is pretty important. Building something at the center of this, combining both visual and location AR, is very much around what we call the visual positioning system. And we're deploying this in several games, and I'll be able to show you some samples here today. So how does this map work? Where does it work? Well, in Singapore, we have over 1,200 places where you can go experience this visual positioning system today, and we have applications out there that are using it. But building a map like this is very hard. We use the content from our developers, from our users, Ingress and Pokemon Go, to collect videos and scans that are then used to build these maps. And these maps are much higher resolution than any maps that I've built in the past, even in my 10 years at Google. And we're able to build this without any LiDAR at all. The other challenge is keeping this data up to date. The world's ever changing around us, and as you get higher and higher in your resolution, the world changes even more. And so we're learning a lot about building accurate maps. As you can see, this is the kind of detail that we need to be successful. We have this in hundreds of thousands of locations around the world. And you can build your games based on that kind of pedestrian-style walking experience and walking location. So what does VPS actually look like? Well, we've deployed it in Ingress very recently as part of the AR overclock feature. And so we are able to verify that an Ingress person is actually at the location in question. And this, I think, is a very interesting challenge because a lot of people in Ingress want to take over the geography, but they sometimes aren't really there. This guarantees that they are definitely there, so it takes GPS spoofing to another level. We can, I think, stop that completely. Much more interesting visually is the ability for developers to create their own VPS experiences. So this location here is not one of those 1,200 that I showed you. They scanned and created this location as a developer and then were able to integrate a very realistic 3D experience into one of their own developer wayspots. So we allow developers to create new locations if it's not part of our world already. And on the right, you see EighthWall using VPS, and on the left, you're seeing the ARDK version. So today, I'm going to talk about three things that we're building and have some new capabilities for. We have Lightship, ARDK, and Maps. We have EighthWall. And then Shared AR, I'm going to go into some depth a bit later about both what we're doing and what comes next. So let's start with ARDK 3.0 and Maps. So we built ARDK for several years. In fact, we've been working on it for over 5 years. We released our first version 2 years ago. And the reason we did it was we had this game idea called Peridot. Now, you're in the Peridot conference room. That's a complete coincidence. But Peridot is the first purely visual AR game at scale. And we had 124 million views on TikTok in our first few weeks. We had well over 2 million downloads. And people are having this great experience with this character. So what does it look like and why does it matter? So Peridot allows us to showcase some of the capabilities we've developed in AR. And first one is semantics. So the ability for us to look out at a scene and recognize different aspects of the scene so that the character can interact with it. So as you walk around, you can recognize the flowers. It can see that the TV is there. And recognize the different forms of the grass world around it. But we also created a lot of other capabilities for Peridot. Real-time mapping. We had location-based AR, so again, showing those way spots, but in the physical world. We have a much better occlusion model. And finally, the sort of real-world understanding. I love this demo on the right because you can't really tell who's chasing that ball and who got it. So this character really feels like they're part of the world you're in right now. And so Peridot drove the development of ARDK. Today, we're launching ARDK 3.0. We're in beta 3, and we're coming out with beta 4 very soon. And there are a lot of new capabilities I'd like to talk about. So ARDK enables all the things you saw with Peridot, as well as the visual positioning system. And it allows you to have capability and compatibility across many devices, including non-LiDAR-based phones. The biggest change in ARDK 3.0 is that it's now completely compatible with AR Foundation. So if you've already built an AR Foundation app, you can add these capabilities to your game right out of the box. Another big addition is shared AR with VPS, and I'll talk about that in a minute. We have a much better debugging interface. And I think the content authoring, one of the challenges we've had with visual positioning is easily deploying content in the real world. And if you go through the development flows and production flows in ARDK 3, it's so much easier to work with. In fact, to install ARDK now takes less than 2 minutes. And this is much, much faster than it was before. So we're very excited about it. Would love to get your feedback. If you're using it, come talk to me. But we have hundreds of developers already working on ARDK, and we have over 50, I believe, developing in ARDK 3 beta as of this moment. So give it a try. So the other thing that we learned in developing all these games over the years is that maps are very important. And working 10 years building Google Maps, I certainly had that lesson explained to me and taught to me by our users. But the maps that we need for gaming and for orientation are different than what is provided by Google. You need a pedestrian-centric, location-based system that is easy to use in the environment you use it. And so we have the Maps SDK available in Unity and available in EighthWall that is very easy to use and provides a backdrop in vector form for your game. So if you'd like to add maps to your experience, whether it's a web-based experience or a Unity-based one, we've made it very easy to do, and we take care of updating with the latest maps data that's available. Next slide. One example of this is Skatrix. So Skatrix was an existing AR skateboarding app made by Reality Crisis, and they took our Maps SDK and actually added an entire maps-based experience to the existing game. And so you can see that they were able to migrate from a local, narrow, sort of virtual skate park experience into one that actually maps to the real world. And they can use our mapping information about which locations make sense to deploy it in. And in some cases, they can even use our visual positioning system to precisely place the skater and do physics between the objects and the real world around. Next, I'd like to talk about EighthWall. So EighthWall is our web-based AR experience. So for those of you who haven't tried it, you can simply load a QR code, go to a URL, and immediately be dropped into an AR experience. And it uses the capabilities that are available in web, which is not as in-depth as the AR Core and AR Kit that you find in Android and iOS, because not all of that is exposed in web. So we've had to build quite a bit of it in our own web system. And I think the experiences are varied. We have over 500 in our showcase, and thousands of apps overall have been built with EighthWall. Today I'm going to be talking about two things: metaversal deployment and GenAI modules. So one of the biggest things about EighthWall is that it's cross-platform. It runs on your phone, and it also runs on mixed reality headsets. And in particular, we got it working on the Quest Pro and the Quest 3. And it allows you to write an app once, run on your mobile phone, and also have that same app working with headsets that are already out there. We're very excited about mixed reality because these new headsets give us the opportunity to try all the aspects of AR while being part of a VR headset, volume-based. So the Quest Pro 3 is exciting because it's shipping this year in volume, And of course, the Vision Pro is incredibly exciting once it ships in volume. But it's a great, I think, development and experience platform already. So one of the first examples of this that we created was Meatwall, or Wall, which is an owl that interacts with you about the real world, and in particular about the forest that he lives in. And what's interesting about this is we were able to create this in EighthWall and deploy it on your phone. So you can try this on your phone right now with meetwol.com. And you can experience what it looks like. You can also run it on one of the MetaQuest Pro headsets, and you can try that out at the Niantic booth, which is front and center once you enter the exhibition area. And this ability to deploy a Gen AI-based character in an augmented reality experience, very, very quickly, and have it used by tens to hundreds of thousands of people just in the first few weeks it was out, I think shows how quickly this kind of technology can be deployed when you make the development platform easy to use. And I think that's one of the strongest arguments for EighthWall. But that was a demo, the application that we built. What we learned from it was that to deploy Gen AI in EighthWall, you need to figure out a way to have the third-party APIs integrated into your web-based application. And it's actually pretty hard to do in combination with a web-based system, because your key for using ChatGPT or DALL-E or InWorld, you don't want to expose that to an end user. And so we've created this Gen AI module for WebAR that lets you integrate ChatGPT, DALL-E, and InWorld into your EighthWall games. And so, if you found a great application that uses ChatGPT, GPT 3.5, or you've started to develop one of your characters in InWorld, or you want some of the image generation of DALL-E, we have the ability now to combine that with EighthWall in a very seamless fashion, and also securing your key so it's used only for the application that you're deploying it for. So, very exciting, and as we've seen in many of the prior presentations, Gen AI is coming. And as Ori said, I don't think Gen AI is replacing XR, AR in any form. But I do think that the ability for Gen AI to create worlds around us that understand the world around us will make AR and VR more interesting more quickly than we would have otherwise. So I actually see Gen AI accelerating what we're doing. And here's a simple visual example of that. So one of our developers basically combined Stable Diffusion and EighthWall and allowed you to author your own skybox simply from drawing it. So this is something that you can go do right now in EighthWall. And this ability for user-generated real-world content, I think, is one of the big changes that we're going to be seeing in AR and XR overall. So now, I'd like to talk about shared AR. We have basically said that for many, AR is a relatively solo experience. And we learned a lot in our development of Pokemon Go and the usage of it, that having multiple people see the same thing and interact with the world in the same way was very important. So if you remember back in the early days of Pokemon Go, if there was a Snorlax over there, everybody saw the same Snorlax in the same location, and so they would run to go try to catch it. And that was important because one of the hardest parts of augmented reality is if you see something and everybody around you doesn't see it, they kind of think you're crazy. So it's very important to have a good shared experience. And you can do that in the geography sense pretty easily. But to see it in precision is actually much harder. We've added the capability to have multiple users enter and share content and share location, precise location, in both EighthWall and in ARDK on Unity. And so in EighthWall, we have this lobby module that allows you to build a web-based experience where everybody shares exactly the same content very, very quickly and sees the same thing at the same time. And I think this making this easy to use and making it low latency and making it scale to a relatively large number of users, I think is going to enable applications that are much more interesting and much more compelling over time. On ARDK and using the VPS, we can now enter a shared AR experience, not by typing something in or meeting with somebody, but simply by localizing oneself at one of these POIs, like the Gandhi statue in the Ferry Building in San Francisco. And so these users are sharing exactly the same view at precisely the same location. And if you look at some of the capabilities this enables, it's pretty impressive. The most important part is it's integrated with existing Unity, including netcode for game objects. But the idea of colocalization is new, and I think the experiences it enables are pretty impressive. On the left, you see a demo that we've been building at Niantic to just test the capability. But on the right, you see something that's very exciting. So a group called Matter has built an application, Hot Dark Matter, which allows you to play laser tag at one of our VPS locations. And multiple users enter, and once they're there, everything about the game is lined up exactly right with very low latency. If you watch the player shooting here on the right, the tracking of where the source of that goes is tied exactly to where the player's phone is right now. And this makes everybody really believe they're seeing the same thing. It's also very hard to get precisely right because as you move your hand around, and if you don't know exactly where you are, GPS is no good. But a visual positioning system can provide that few centimeter accuracy that makes these games really believable. And especially when you're playing in sort of a shooting game, trying to target people, it's really important. So if you haven't tried it, give Hot Dark Matter a try. It was launched, I think, in soft launch just a couple of weeks ago. So how does this work around the world? Now, I have a theory about connecting AR everywhere. And one of the challenges that we've experienced is that even in the highest volumes of 2016, when everybody's playing Pokemon Go, or for example, just last week in New York City when we had our Pokemon Go Fest, and we actually had 100,000 people in New York City playing Pokemon Go at the same time. Getting people into the same place at the same time is sometimes hard. And so being able to share your experience that you're experiencing locally with a remote user is, I think, very important. So imagine that you capture one of these physical locations, like this space right here, statue, and you create an AR experience where you're localized physically and standing where the person on the left is with the statue. But I'm now wearing my headset, my MetaQuest 3 headset, and I can see that same 3D model and interact with it in the same way, and both of us are interacting with the location at the same time. So this idea of combining AR, VR, and MR, and being able to do it simultaneously, I think allows us to bring everybody, both sitting on their couch, standing in their living room, and those that are out in this outside world together and have a shared experience. And so this being able to be cross-platform, cross-location, cross-style, I think goes back to Professor Billinghurst's idea of a mirror world combined with augmented reality. And that speech actually spoke to me very well. I think that's what we at Niantic do. We're trying to combine all the capabilities and allow you as a developer and creator to be able to implement your experiences that have the same power. And as we learn more, as we develop more games, I think we'll be able to bring those technologies to you. And if you build on our platform, you'll be able to have the additional learnings and additional capabilities added over time. So with that, our goal, like Ori's, is to do AR everywhere, all at once, for everyone. Thank you.